So notice it says right here at the top, it says more rate problems. So let's actually circle that. In other words, when we're working with rate problems, the very first thing we write down after we're done going through all the words and crossing out, underlining, circling, whatever, is we write down the rate that is, the type of rate that is happening in the problem. Okay, so share with me some of the things you did with the words. Do with some of the problem. Chloe and Logan are running toward each other. But, Tyler.
They're running towards each other at 5 feet per second.
Okay, they're running toward each other. You underline that?
I would put Chloe's running at the rate of 5 feet per second.
Oh, this one. Okay, Chloe is running at the rate of 5 feet per second. That seems to be important in this problem. Okay, good. Somebody else. What else? Sammy.
I crossed out Chloe and Logan are running each other.
Okay, Chloe and Logan are running towards each other. They are going to help us with a little diagram we're going to draw, but in reality of setting up the equation, it probably isn't necessarily so important. Okay, Caden.
Logan is also running at a rate of 5 feet per second.
Okay, Logan is running at a rate of 5 feet per second. Oh, well, what does that tell you guys right there? What does that tell us? If they're both running at a rate of 5 feet per second, what's true? One faster than the other? No, they're running at the same rate, aren't they? Okay, well, not necessarily that's going to, who knows if that'll be important in the problem, but it's worth observing. Okay, something else. You got something for me, Sierra?
It's about how long will it take them to pass each other?
Okay, how long will it take them to pass each other? So how long, I'm just going to circle the how long for right now. And then notice what I put in parentheses, or meet, in other words. Because remember, they're running toward each other, aren't they? So they're going to pass, meet, and we're going to find that point where they are actually going to not run into each other, but pass each other, okay? Anything else that I think we could do? Anything else that you did or you think we could still do? Sammy?
They are 200 feet away from each other.
They are 200 feet away from each other. Okay, that seems kind of important also. Okay, now that we've done all of that, I want us to, before we even worry about trying to draw a diagram, set up an equation, I want us to identify the rate. This is a rate problem. So what is the rate in this problem? What is the rate in this problem? Got it for me, Paikia?
5 feet.
Not 5. We're not going to have the 5 involved. Okay, go ahead, Paikia. I'll give you another chance.
200 feet.
No, we're not going to have the 200 in this part. We're just the rate that is happening without any numbers, okay? Without any numbers. Sylvia?
Seconds.
Well, not quite. You're pretty close. Danny? Feet per second. A rate has to be two things being, two units of measure being compared to each other, and they're different. So in this one, the units of measure are feet per second. Okay, so the first thing we always should identify is our rate. Then what's the next thing we should do with that rate? Times it by something to get rid of the denominator. What should we multiply by then? Seconds. So we're going to multiply by seconds. This is going to show us what our multiplication problem should look like in our equation. So these guys will cancel out, and what we get from our multiplication should really end up being feet then. It should be representing feet. That's the first thing we need to do. Okay, now the next thing we're going to do is we're going to describe x. X is representing the question being asked. So what's our x going to be? Number of seconds, because it says how long. So we're going to say x is number of seconds. We get to abbreviate in this part, not in sentences, but in this part we get to. Okay, well they asked us to use arrow diagrams, so we're gonna go along with that. They're running towards each other. So here's Chloe. She's headed that way. Let's just call this arrow Chloe. And Logan is coming towards her. So there's Logan. And it says they are 200 feet away from each other. So from where Chloe starts to where Logan starts, that's a total of 200 feet. So let's put here that we have from the beginning here to the end, we have 200 feet. And we're looking for how long it's going to take them to meet there. And I think I'm pretty safe in saying they're going to actually meet in the middle. Why do you think I'm safe saying that? Why would they meet in the middle? Why should they meet after 100 feet each? Why do you think? Do some critical thinking here. Why should they meet after 100 feet each? Why should they actually meet in the middle of this 200 feet? What do you think, Tyler?
Because they're going 200 feet and both have to really
And they're both running what, at the same, same rate, aren't they? They're both running 5 feet per second. So they're running at the same rate, so in reality, they should be exactly in the middle of that 200 feet, shouldn't they? Okay, but we're looking for how long it's gonna take them to get there. Okay, so we're going to say this is gonna be our Chloe. And then we got Logan. And then we know that altogether there is a total. So to help us set up our equation, this is what we're gonna have. Anybody set up the equation yet? Anybody got it? Danny, what is it? I'm sorry, what? 5 times x for Chloe, okay. Plus 5 times x for Logan, okay. Should equal the 200, okay. What do you think, class? Think that's what we can do? Yeah. Because what does 5 times x represent again? What should we get out of that multiplication problem? If we're multiplying, so not only should we just know how to do these, but we need to understand them. That's going to help you be really, really good word problem solvers. When we do this multiplication for Chloe, 5 times x, tell me what that 5 times x actually represents. No? Look up here. This is our multiplication right here. Feet. The seconds cancel away. Remember, the seconds cancel away in our multiplication problem. So maybe we should put this here. We got to start understanding what's going on here. 5 times x should give us the number of feet Chloe runs. 5 times x should give us the number of feet Logan runs. And altogether, they're going to run 200 feet. What we're adding in our problem better give us something that makes sense. If we're adding seconds to seconds and getting feet, that's a problem. That's not going to happen. Okay? Now let's go to that work page. And let's write down our equation, 5x, because that's what 5 times x is, right? Another 5x, so plus 5x equals 200. And now we'll solve it. Well, wait a minute. Does this one ready to solve yet? Does it need some getting ready? Needs some getting ready. What are we going to do, Wade? Combine the x's. Okay, so how many x's are there all together, class? 10. So this is just a getting ready step. That's not a solving step yet. We would call that a simplifying step. Now I think we're ready to solve, aren't we? What are we going to do to both sides? Divide by 10. Divide by the coefficient on the x. And that's going to give us x. How many 10s are there in 200? 20 of them. You know, if you look back at your other sheet, I bet you know what kind of a label you need to give that 20. What is it? 20 what? Go look at what x is. What's x? Seconds. This is seconds. And before we go back to our other sheet and write our sentence, let's answer these questions that I posed here for us. Let's decide if this makes sense. How far will Chloe run? Well, how fast is she running again? 5 feet per second times 20 seconds. How far will Chloe run? 100 feet. Oh, we kind of started talking about this already, didn't we?
How far will Logan run? Well, Logan's running at 5 feet per second also for these 20 seconds. And so guess what? He's also going to run 100 feet. Does that add up to 200 feet? 100 plus 100 equals 200. And you're right, we get to say yes. So now, since we decided our answer seems pretty reasonable, it makes sense, let's go back and write a sentence answer back on the problem page. So, question was, how long will it take them to pass each other? What's our sentence going to say? It will take 20 seconds, okay? To pass each other, right? Not run into each other. At that point, they can high five each other, right? We're getting good at these, aren't we? How are you feeling? Feeling pretty good about them? Okay. Tackle another one then, because we're having so much fun. Trucks move freight every day up and down the state of Florida. Guess what they do in North Dakota too, don't they? Across the state, and probably more than up the state, but if you're out on the interstate, you see a lot of trucks, don't you? A2Z, that's an interesting name. A2Z Shipping Company has warehouses in Miami and Jacksonville. 2 of their trucks start in the morning at 9 a.m. Ethan is driving the truck from Jacksonville on the freeway at 65 miles per hour. Aubrey has a heavier load and is traveling from Miami at 55 miles per hour. The distance between the Miami and Jacksonville warehouses is 360 miles. How long before the trucks pass each other on the freeway? How far will Aubrey be from Miami when they pass? Now I'm going to guess that the first question they're asking is probably the first one we should find the answer to, right? So let's kind of ignore the other question for the moment. Okay, what do you think we should get rid of? What should we underline? What should we circle? What kinds of things can we do here? Maybe we could start our arrow drawing before what's happening here? Ethan is in Jacksonville, Aubrey's in Miami, and we want to know when they're going to meet, right? They're going to pass each other. So are these guys coming kind of like Logan and Chloe were? Okay, let's do this then. Let's just take a moment and come down here. Leave some white space for our other stuff we're going to do here. So this is Ethan. Kind of want to rename him Truman because my twins are Truman and Aubrey. Ethan and Aubrey, and all together, how far apart are they when they start? Well, maybe we should wait till we find that in the information. What can we underline? What can we cross out? What can we circle? Tyler, give me one thing to do.
We can cross out trucks move freight every day up and down the state of Florida.
Oh yeah, that's, we're like, yeah, they do in North Dakota too. Okay. What else do you want me to do? Okay, I'm just going to give everybody a chance here. Derek, give me something to do.
You can cross out A2Z Shipping Company as warehouses in Miami and Jacksonville.
Yeah, that's, it's important that we kind of know why these guys are trucking, but, not really going to help us set up the equation. Okay, what else? Paikia, you're next.
You can cross out 2 of their trucks starting
Yeah, that 9 in this problem isn't really going to have anything to do with our equation, and let's get rid of it. Hayden. Okay. That seems kind of important. Okay, what else? Sylvia. Aubrey? That one?
Aubrey is
Has a,
has
heavier load.
heavier load and is traveling more
From Miami,
uh, by 55 miles per hour.
okay, so it kind of seems like the one that Aubrey is traveling from Miami at 55 miles per hour. That's really kind of the important part, isn't it? What is the heavier load? Why did they throw that in there? What would be the reason for throwing that in, I wonder? Sylvia?
So there's a reason
Yeah, so we know the reason why she's going slower, yeah. So, but it's not really that important for us for solving, is it? Okay, let's see. Wade, would you give me something? Did you want me to
Also,
do?
the distance between Miami and Jacksonville warehouses and circle.
Cross that out? You don't think that's
and-
important?
And circle 360.
Oh, so you think what's important in that is the 360 miles. Okay, but I think it's kind of important to say that that distance between them is 360 miles, because that kind of shows a total, doesn't it? So we're going to come down here right now, and we're going to say, you know what? They're 360 miles apart from each other at the beginning. Okay. And then we're only going to worry about the first question right now. It says how long before they pass each other. Okay, how long? Let's worry about that right now. Okay, don't you even think about setting up an equation until you do what? Write the, there's our rate. Write the rate. What is the rate in this one? Miles per hour. Well, in our equation, when we're setting up our equation to multiply, what should that be multiplied by? Because we can't have two labels going on. What should it be multiplied by? Hours, okay. That means whatever we get from our multiplication problem should represent miles. Okay. Next we do what? No, we don't solve the problem. We haven't got something described. What's the idea?
The X
The x has to be described. So x is what?
number of hours.
X is the number of hours. How long? Okay. Maybe now we're ready to set up an equation, right? But we got to put their names here. We got Ethan. We have Aubrey. And we have a total, we decided. Okay, starting out, different places, we want to know when they're going to meet. And the distance between that is between the two of them, they got to cover 360 miles. So what are we going to do for Ethan? What's our multiplication problem for him? Everybody say it together. Thanks. Are we going to add to Aubrey's? Okay. Ethan's going to cover some of the miles. Aubrey's going to cover some of the miles. What would our multiplication be for Aubrey, class? 55 times x. And altogether, they're going to cover 360 miles. How are you feeling about it this time? Do you think they're both going to cover the same amount of miles? Are they going to meet in the middle this time? I don't know. Why not? They're not going the same rate, are they? Who's going to cover more miles? Ethan is. He's going faster. Yeah, he's cruising. Okay, let's go to our work page. And this, write our equation. We have, our Ethan is first, isn't he? 65 times x is 65x. Aubrey is 55 times x, that's 55x. And altogether, they are covering 360 miles. Miles plus miles equals miles. Ready to solve?
Oh my goodness.
No, not yet. It's not ready yet, is it? We got to combine the x's. So how many x's are there? 65 plus 55. How many is that? 120, okay, 120 X's. Yeah, we're finding out how many X's there are right now. And when we take that 120 times that X, that will give us how many miles, okay? So, is it ready to solve now?
Yes.
Yes, okay. Let's go then. What are we gonna do? Okay, divide by 120. Did you know that sometimes when division doesn't go very well for you with big numbers? Wade and I were just doing this last night. When you just keep adding, so since we're dividing by 120, we could say 120 plus 120, that's, sometimes adding's easier. What's 120 plus 120? 240. Well, that's still not enough, is it? We need 360. So we would add 120 again. How much is that? 360. So now all we do is count up how many 120s did it take to get to 360. It took 1, 2, 3 of them, didn't it? So x equals 3. So sometimes when you don't get to use a calculator and you just don't, there's not a table to help you with this kind of a division, then do something like that. That'll help. 3 what? What would this be again? Hours, okay. Okay, so now we are ready to go back to the front and we're going to write our sentence answer on the problem page. And the first question was, how long before the trucks pass each other on the freeway? So we're going to say what? It will take 3 hours. To pass each other, to be able to honk their horns. As one's heading one direction and the other's heading another. Okay, so now we're going to go back and the second question says, how far will Aubrey be from Miami when they pass? How far? So that's going to be what? Miles, right? Okay, so let's go back to our work page where I think I gave us the opportunity to. So for the second question, Aubrey is leaving from where? Miami, okay. And how far has she traveled in 3 hours is really what we gotta find, right? Okay, so what are we gonna do? How fast is that Aubrey driving again? 55, so remember it's 55x, that's Aubrey. 55 times x. So let's show 55 times 3. That should tell us how many miles she is going to drive. Well, what's 3 50s? 50 plus 50 plus 50 is 150. And 5 plus 5 plus 5 is 15. And 150 plus 15 is, look how good we are. And that's 165 what? Miles. Okay, so now let's go back and answer the second question. Aubrey will be 165 miles from Miami. Now the reason I didn't ask us to talk about reasonableness right with the 3 hours is because, maybe we can't, it's kind of hard to make sense of the 3 hours but now that they asked us the second question, do you think 3 hours seems reasonable? Because it says Aubrey will be 165 miles from Miami and we already decided who's going to go more miles? We already decided Ethan's going to go more miles because he's driving faster. So would Ethan be driving more miles? Can anybody tell me how many miles Ethan would be driving? How much of this distance is Ethan gonna cover? Get a couple of ways you can go about it. Sammy? 195 miles. So you rested with that? Yeah, so do you think we got a reasonable answer? Yeah, Ethan's going to be, he should be covering more miles because he's going faster. And so we said 195 for him, 165 for Aubrey. I think it seems like we did a pretty good job. Again, we are not just going to do math problems anymore to just get answers. We want them to be reasonable. We want them to make sense to what we're solving, okay? One more, but I crossed out the last one, didn't I, on the back side? I hope so, anyway. Okay. Now we have Amelia and Addison, who are sprinters on the track team. Anybody here in track team right now? No tracksters, huh? Okay. They decide to have a race where they start at the 50-yard line of the football field. They'll run in opposite directions to see who can get to one of the goalposts first. So they got this race going on. And Amelia runs 15 feet per second. Addison runs 18 feet per second. How long before they are 99 feet apart? Oh, there's two questions. We're going to ignore the second question for right now. Okay. Well, what do you think? This is kind of nice to know, yes, that they're on this track team. They decide to have a race where they start at the 50-yard line. Are we going to need that 50 in our equation, do you think? No. So let's get rid of it so we don't think we have to use that number in our equation. This picture here shows us they're starting at the 50-yard line. They will run opposite directions to see who can get to one of the goal posts first. So this time they're not meeting in the middle, we're going out. So let's do this. Let's say we got one of them is going this direction, the other one's going that direction. One of them is Amelia. The other is Addison. So they will run in opposite directions. Now that we've done that on our picture, we can get rid of that part. Amelia runs 15 feet per second. Important? Probably, yeah. Addison runs 18 feet per second. That's probably important also. How long? That's going to be our question first. They are 99 feet apart. So the distance from where when one of them, when they're running, it doesn't say which one gets to the goal post first. It says when will they be 99 feet apart. Anybody know how long a football field is from goal post to goal post? 100, but then there's this also this kind of like thing that we have this end zone also, and then but that's measured in yards. This is what, 99 feet. Well, 99 feet is how many yards? How many feet in a yard? 3. How many 3s are in 99? 33. So they're really only going to be 33 yards apart. So are either of them going to be able to get to the goalpost in this time that we're talking about? No, the question wasn't how long will it take them to get to the goalpost. It says how long before they are 99 feet apart, which we just decided is 33 yards. But what is their feet per second? So we're going to keep it as feet. So we're going to say from here to here has to be 99 feet. Okay? They're going to be 99 feet apart. Okay, our rate is feet per second. We need to multiply by what? Seconds. So that our multiplication problems will be the rate times seconds. The seconds will cancel away. Our multiplication problems will represent feet. X is the number of what? Seconds. We're looking for how long. And we already have our picture, so we are ready to set up an equation. We got, let's call AD, AM, and we know they have to run a total of something. So, what's Addison's multiplication gonna look like? Cadence? 18 times x. So Addison is running at a rate of 18 feet per second times the number of seconds. So we should get 18 times x should get us how many feet Addison runs? Is this a plus problem? Yeah, because together there's a total amount of feet they're going to run. How about Amelia? What's her multiplication going to be, class? 15 times x, and that also is going to represent how many feet Amelia runs. And all together, we want to know after 99 feet, right? Okay. You go get that all done on the work page. What does x equal? 3, and those are seconds, you say, okay? Then you're ready to go write the first sentence answer. Go write your first sentence answer back on the problem page. It will take no abbreviations, capital letters at the beginning of your sentence, punctuation at the end of your sentence. And then while you're on that page, read what the second question is, and then we'll pop back to the word page. Are you writing it? Wait. Just be finishing up here. I'm not writing the sentence, you are. Okay, what do they want to know in the second question? How far who is?
How?
Addison? Okay, from the 50-yard line. Is that where they started? Yeah. So how far Addison is from the 50-yard line. So we're going to figure out how far he can run in how many seconds? 3 seconds. So Addison, remember, he's running how fast? 18 feet per second. That's the 18 times x multiplication. So we're going to take 18 times 3, and that should tell us how many feet away from the 50-yard line where he started Addison is. So 18 times 3, what is that?
54.
54. You guys are fast. 54 what? Feet. Okay. Well, let's kind of just quickly see if this seems reasonable or not. Remember, altogether they're going to cover 99 feet. Is this more than half of 99? Is this more than half of 99? Because half of 99 is really close to 50, and 50 is half of 100, and this is more than 50, so this is more than half, isn't it? Okay? Should it be more than half? Why? Why should it be more than half? Why should Addison run more than half the distance? Tyler?
Because he's running 18 feet per second.
He's running faster, isn't he? He's running 18 feet per second. So we can feel pretty confident that we have a pretty good answer here. So we'll go back to the problem page again, and we'll finish with our second sentence answer. Addison will be what? 54 feet from the 50-yard line. Okay, bonus points if you can tell me what yard line you're on. Candy, I have candy up here. Whoever can tell me well, now. What yard line is Addison going to be on? He started at the 50. He ran 54 feet. Everybody get an answer, and then I'll give the answer away, and whoever really truly got it gets some candy out of the basket. Quickie. Give everybody just a few more seconds to try and figure it out.